In this video, we're going to configure the pulse pnmr apparatus to make a T1 measurement. A T1 measurement requires the application of a 180-degree pulse followed by a 90-degree pulse. So we have to configure the A pulse as a pi pulse, or 180-degree pulse, to rotate the population or the spins that are in equilibrium with the static magnetic field to be completely inverted now, rotated by 180 degrees relative to that static magnetic field. And then we need to follow that with a B pulse, which is at 90 degrees. So using some of the similar logic that we did for the T2 measurement in this T1 measurement here, we'll use some logic, look at the amplitude, and see if we can get the A and B knobs, in other words, the width of the pulses, configured as needed here. So if we want a 180-degree pulse, let's do it as follows here. At the moment here, I'm syncing on A, so this is the A pulse right here. The yellow curve is the response to the detector. The B pulse is off, and I'm only applying one A pulse, which turns the RF on at 15.41 megahertz. So if I start turning up the A amplitude, you see it gets nice and large there, but that's a 90-degree pulse, as we discussed in the previous T2 video. But I don't want 90, I want 180. So I'm going to continue to turn this until it minimizes again. Right about there. Minimizes right about there. And I shouldn't really do this, but I'm going to change the resonance frequency to stuff so it gets worse. So it gets worse maybe like right in there. So I really want to get it as small as possible. Okay, so now I'm pretty sure that the A pulse is inverting the population or applying the pi pulse as needed. So what I'll do as before is I will turn the A pulse off, turn the B pulse on, and then synchronize on B. So this looks again just like the A combination, the A response combination, but this is the B pulse because the A pulse has been turned off. Now the B pulse is supposed to be 90 degrees, as we mentioned. This T1 measurement requires a 180 and then a 90 pulse combination, or a pi, then a pi over 2. So once again, I'll turn the width of the B pulse up till it gets really large, like right around there, and that's exactly where I want it to be. So it's really large like that because I know I'm rotating the population that's in equilibrium with the static magnetic field along the positive z-axis. I must be rotating at 90 degrees into the plane of the detector so it gets nice and large. So in this combination here, I'm pretty confident that the A pulse is applying its pi pulse, or 180-degree pulse, and the B pulse is applying its pi over 2, or 90-degree pulse. And once again, I can look at the knobs, the marking on the knobs. It does look like the A width is about twice the B width, and that's what I want. So to get this T1 measurement to work now, I will turn the A pulse back on, and I will synchronize on A just so we can sort of see what's happening here. Let me see if I can zoom in a bit more. Yeah, here we go. Okay. So what's happening in this particular case here is there's the A pulse, and then here's the 10 millisecond delay as set on the apparatus right here. 2 milliseconds per division, about 1, 2, 3, 4, 5. It's about 10 milliseconds there. And then right in here is where the B pulse got applied. Let me see if I can sort of bring the B pulse out. Yeah, there's the B pulse right there. The B pulse gets applied, and then here's the response, which is this yellow part of the curve that you can sort of see in there too. Let me maybe orient it like this. I'll lift this up a little bit there. So you can always see the pulse is applied there, and there's the result right there. And so the curious part about this particular experiment, as contrasted with the T2, is if I zoom out like that, we don't see an echo out here anywhere. And that's how we know we're doing the T1 measurement. So everything seems very similar, but the width of these pulses here throws us in an entirely different regime, so we just don't see an echo signal anywhere out there. And you might be thinking, no, there's the echo signal right there, but no, it's not. That's where the pulse NMR apparatus cycles again on the next cycle because we have it set to repeat all of its pulses and measurements every 100 milliseconds, so we can't quite zoom out that far. So nonetheless, this will be our measurement. So what we're going to do now is we are going to track the amplitude of this pulse once again, this return pulse from the detector once again, as a function of delay time between the A and B pulses. So it will seemingly feel like a very similar measurement to T2, which was covered in a previous video, but it is not. The pulse sequence here is entirely different, but the data will be the same. We'll still be tracking the amplitude of this signal as a function of the delay time between the A and B pulse, and we'll start doing that in the next video.